Today we are starting to do our home automation system. In a previous video we had discussed our philosophy on home automation, what components we were using, how we were getting them to dim lights, the concept of graceful degradation and how we were programming that in. So now all of that is turning into this is what we're going to put in. But for now we're focused just on lighting, just on controlling what these lights are doing, how they're on, how to turn them off and on, how to dim them, things like that. Unfortunately, we've needed light this whole time, so you can see all the lights in the coach are literally on right now. And when we run all the light, we made a measurement, we're only pulling about, I think, 6.5 amps. It's not a whole lot of power because they're all LED. What we've done for right now, and you can see it's kind of a rat's nest, is we've just used these Wago connectors to just get them in temporarily. All of the switching is done on the negative leg, and that's because we use what's called an N-channel MOSFET to do the dimming. And so these will control the logic and they'll listen for inputs from all of the switches and things like that. The big thing is space planning. So we've decided that we're going to have 2 of these processors controlling something like 18 lights, and then there will be a number of buttons coming in, 4 different panels, each with 3 or 4 buttons each. And so they'll have to listen for that. There'll be, I think, 5 MOSFET boards, and then we'll have a 12 to 5 volt converter because all of this stuff works on 5 volts. And then we'll have a 12 volt component, and that's what actually powers the lights. So all of that stuff is going to have to fit in this little cabinet. So Michelle is the master at space planning, so she's already gone ahead and started laying things out and where a wire's going to go and how are these going to go. We've drawn several pictures, and we're going to get going on this project. Alright, so we've made up some little standoffs for the processors, and what we did was we just cut a 2x2 aluminum angle into basically a 5/8 inch strip and then just VHB'd it. It'll allow very easy access to both of these buttons, and more importantly, it allows us very easy access to the USB port, which is what allows us to program these things. Also, on the rear, it's got all these pins. These pins will be connected to different circuits to allow for like reading of input buttons or to send signals to lights to turn on. And to keep all that orderly, what we did was order these, they're Molex connectors, and there's 19 pins in this particular model, and they just literally just push right in. And so we have a crimper and these little cables here, this roll of cables, and we just crimp and then slide the pins in to the positions that we want. So we'll probably have about 18 wires or so going to each of these little processors, which will then go to MOSFET boards. One of the reasons we've done that is if one of these processors goes bad, we would just pull 2 of these off, pull this off of the standoff, we'll program it, glue another one on there, put the 2 connections back on, and we're up and running. These are the MOSFET boards we're using. The inputs or the signal wires go on top in those 4 black pins, and the bottom there is where the outputs go. So those will go directly to the lights. So we're going to now mount these up and inside. So we've just VHB'd the rear.
That's good.
Yeah. There they are installed. So we're going to run control wires from these boards to these MOSFET boards, and then the last thing we'll do is connect these lights. We're getting ready to start wiring up some of these CPUs or the ESPs, and so Michelle's gone ahead and drawn a diagram of how we installed. So each one of these is a MOSFET board, and then these pins are the ones that are going to be assigned these to ESP2, and then this set of 2 to ESP1. And so we're going to color code them. One's green, one's yellow, one's blue. And so we've gone ahead and cut a bunch of green wires that are going to be too long, so we'll have to trim these down to the right section. But what we're going to do first is we've bought this. So this is a Molex crimper. It is used to crimp these tiny 22 gauge wires. They're just carrying a signal. They're not really carrying any kind of load, so they don't have to be very large. So what we found though was with these Molex connectors, about 22 gauge is what they like. We were able to put Ethernet cable in here, which I think is 26 or 24, and it was okay, but it liked this wire much better, so we're using that. So we know what pins they're going to go in. We've already planned that all out. Michelle and I sat down and wired that all up. So on this, we can see where the pin layouts are. And so we've kind of circled and defined what we're going to do.
Okay. So, just a tiny bit. Okay, go ahead. Yeah? Okay. In.
Click.
Yeah.
So this is what it looks like when they're done. All right, so we've got these wired in. You can see the little plugs here. So Michelle went through and sized each one. The way these work is these little pins are a little 3-wire connector, and they plug right into the MOSFET board just like that, and they clip in place. Okay.
Okay, so now let's do maybe a little wire management. This is the bottom.
Okay, there it is. So that's one. Up on each other. Okay. That goes in there. Okay. And then 6. Okay.
It might be. So now you're like stretching them really far.
Okay. All right, so we've wired it all up on the input side. All the blue cables go to this processor, all the yellows go to this, and then all the greens go to this bottom one. All the 5 volts have now been tied together, and they come out through a large 14 gauge cable, which should be plenty to supply all the needs there. So we're gonna put in a 12 volt fuse block, which looks like this. And then we gotta put in a 12 to 5 volt converter. This will supply the VCC voltage. So we've got to hook basically this to this, and then hook power. Negative goes up here, and then positive goes down here. Oh, that wasn't too bad.
It's a coronavirus bush.
Does that look okay?
Yeah.
Is that better?
Mm-hmm.
It's in there.
Oh boy.
Is that okay?
Mm-hmm.
Oh boy. Oh boy.
Okay.
Oh.
How's that?
Yeah, that looks good.
What the
just ult us on the site. Dude, I didn't hit her at all. That's my bad.
Alright, so continuing on with our wiring here, we've now put in our fuse block, the 12 volt to 5 volt converter. We've tied in all the positives for the plus 12 volts and the 5 volts. So we've hooked all that up, and so now we're at the point where we are going to start hooking up the lights to these MOSFETs. And so we're about to lose light, so we told the kids, like, hey, the lights are going to be out for a while we figure this out. So we did write a small program last night where all of the MOSFETs that are driven by these two processors will just turn on full bright. So as soon as we put 5 volts to them, they should recognize the program and just go full bright. That's how we'll be doing it for now till we can get all the home automation stuff, because I've got to get an MQTT broker running and all this other technical stuff that you probably don't care about. So anyway, they're just going to turn on full bright, and that's how we're going to test the circuits, test our wiring, test all that stuff. So that'll be the next step. It's just going to be all these black wires coming into here. Now, one thing that we had to account for is if some of this stuff just goes bad and isn't working correctly, we still want to be able to have light. And so what we've done is we've designed a circuit where we'll have some manual switches in here, and we talked about it in our graceful degradation video, but we'll have manual switches in here that will have 4 zones in the bus. So we're thinking like the front, the kitchen, the bathroom, and the rear. So when we flick that switch, it'll just turn on like 4 of these living room lights, and then 4 of the kitchen lights, and the shower light plus the bathroom light, and then 1 row of the kids lights. The way we're going to do that is with a MOSFET. We're going to start wiring these now. So we're going to start with the ones that do not have the emergency MOSFET circuit on it. So it's getting to be less and less like a rat's nest, and it's starting to look pretty good in here. We are going to wire some of these little MOSFETs up, and this is going to be for what we're going to call a manual override for the lighting. The reason we had to use a MOSFET is on a lot of these emergency circuits, we are lighting up 2 circuits at one time, and so we needed a way to isolate the outputs while still, in regular mode, maintaining them as separate. We're going to tie to the source of the MOSFET, we're going to tie just a negative. To the gate, we're going to put it on a switch, and then to the drain we're going to put that out to the light. And so what'll happen is then one switch will toggle multiple of these MOSFETs and turn them on kind of at the same time. And so an example of that is in the front, where we have 2 sets of living room lights that we want to toggle on. The one switch will toggle both MOSFETs and turn them both on, but then if we turn it off, they're independent again to be used with the home automation. So it's a little bit weird. This is what we're doing for manual overrides. We're going to have to make a bunch of little wires off these MOSFETs, get them ready to go, and hook them up to a switch. Okay. I don't know if there's a way for you to help me do this.
Do you want me to just kind of hold the red wire? Or no?
No, this seems like a good connection. Right, that's feeding it up.
Yeah, kind of.
All right, we've got the MOSFETs installed. You can see we've installed them relatively close to the lights or MOSFETs that they will be overriding. And so here we can see these purple wires with the black. So this black here is the main output to the light. This is the signal from the MOSFET board, and then this purple is the signal from the override MOSFET. So anyway, the way this works is the light will take input from the MOSFET board or from the override MOSFET themselves. If both are powered, it'll be powered at 100% because this MOSFET does not switch on and off. It just gives the full negative. It just works like a simple on and off toggle. And so it will give full bright to whatever is manually overridden. Anyway, so these have to be wired up to switches. So we'll be doing that next.
I'm gonna wall it. You have rice.
Not a lot.
And then is number 5 next? Is number
Yes, 5 should
five
come on
next.
the next one.
Okay. Okay, so that goes there. Okay, and then the pairs.
Yeah, and then 9 and 11. Go on number 3.
Okay.
14.
I've read 73 pages.